people are joining.
Probably just give them a couple of minutes for the folks to join. I want the tiles to be like very, very small on the Google Meet, right? That's when we will start the session. So we've got 20 odd people on this call. So we need more and more tiles.
Yep.
Pablo, you can go ahead and share your screen, and we will get started probably in a minute. Probably by 3-4 we will start.
So do you want me to start with the slides and then we can have kind of conversation?
Yeah, you can start the presentation. Amar will kick off the...
I will give the introduction and then we'll take forward.
Okay, let's try this. Nice. And now I need to share the screen. Share the screen.
Are you able to?
Yeah, I hope so. I'm an engineer after all. So, okay. Can you see something?
Yep.
So is it okay or should I make it bigger?
This is fine. This is just fine.
Okay, cool.
Okay. For the interest of the time, I think let's actually kickstart the call. Hi, team. So good afternoon, everyone, and welcome to today's webinar. We are really excited to co-host this webinar along with the CYBERTEC, who is actually the Postgres experts organization from the beginning of the Postgres days. So I myself, the Amar Kaka, the COO of OpenSource DB, and I'll be host and facilitator for this session today. So to get the context in place, so we wanted to discuss more of a the observability as a focus. We wanted to understand and then bring the real-time use cases and discuss in detail with all of you, and then what Postgres really requires to become the most robust, scalable, and then the reliable data platform for you guys. So we will actually touch base a lot of points around the observability monitoring in focus, but you can actually ask the many other areas as well. The things, as I told, installation is easy, but making it as a robust data platform is not easy. It actually requires a lot of an optimal configuration, observability, and then you need to be in control of what is happening, all from the security to the many other areas. So for all of them, observability is the key area, and then only when you control them in a properly, then you are actually in control of your database. So we will actually touch base and explore more of a PG Watch, which is actually the open source monitoring tool developed by the CYBERTEC, along with many other advanced techniques, and then the experiences that CYBERTEC team and open source DB team that actually acquired over the period of the last decade plus. So whether you being a developer or a DBA or an architect, this session will offer the real world strategies, tooling insights, and also some of the lessons learned by us. And then you can actually ask the questions, and then we can actually share the things. So how we are actually doing this one? So it is actually a combination and partnership between the OSDB and then the CYBERTEC. And then OSDB, the open source DB, so shortly we call as OSDB, is a specialist PostgreSQL consulting firm focused on helping the enterprises around India and the worldwide, and especially with an expertise on migrations, and then the scaling, and then deployments, and optimize the Postgres across the hybrid and cloud native environments. And CYBERTEC, who is actually founded in 2000, one of the world's leading PostgreSQL companies, offering enterprise-grade tooling, training, and also 24/7 support operations. This collaboration actually brings both the expertise from services and also the world-class PostgreSQL innovation to your hands. So that way you can actually take the best solutions for the PostgreSQL and then see. To go into the details, let me introduce our esteemed speakers today. So our main technical speaker from the CYBERTEC, Paolo Golob, the senior PostgreSQL developer, and then is not new for many of you. So you might have seen him in multiple conferences and many other places. So he actually writes the code, develops the code, helps the customers to make their environments so up and running all the time. And then he brings an extensive hands-on experience with PostgreSQL internals and performance as well as an observability area. So Paolo will walk you through the PG Watch and also discuss the broader monitoring architectures and use cases, lessons learned from the enterprise scale deployments. So that way you will all get the more advantages of his time, and also you can ask the things. I'm also delighted to introduce our founder, OSDB founder, Hari P. Kiran, and who also brings tons of experience as a PostgreSQL architect across database solutions spanning across the extreme high availability, migrations, data analytics, and security areas. So what you can expect out of this call? So it's an open discussion, and then most of the time you will actually see real-time experiences and real-time things rather than the theory, and you are open to ask the questions. If you have any questions while you are observing and then hearing from Paolo or Hari, so please drop your questions into the chat. So we will actually take it and then address them during the course of the webinar or at the end of the webinar. And if you'd like to have a personal demo or consultative session, also please reach out to us, and then we'll be happy to schedule and then ensure that, okay, among all our solutions, including the observability, we'll be happy to schedule and then actually run through a demo sessions with you. And also don't forget to follow us, both OpenSource DB as well as the CYBERTEC LinkedIn. For all the updates, we have been actually updating and then publishing a lot of articles, a lot of to-dos kind of stuff. So you can actually get, and also a lot of future sessions or future webinars. So if you keep following us, you will actually get the most updated things. So with that, I will hand over to Paolo to start the real technical session.
Thanks a lot. Can you hear me, I hope? Well, yeah. So I will present the PG Watch open source solution, and I want to focus more on use cases, right? Because when I speak at the conferences, I usually provide some general overview of every possible monitoring like solution in the world, how to use it, what to choose, and so on and so on. And usually I don't have much time to focus exclusively on PGWatch. And today I want to show you like some top 10 maybe useful use cases, how you can like just like a scenario, right? So you have like items and you go by checklist and you solve the problem. But first of all, who's me? I'm Pavlo Golub. So I'm working for CYBERTEC as a senior consultant / developer for a long time really already. So I was more consultant, now I'm like more developer, but these roles are always like floating, switching. So if you have any questions and if you want to reach me on any social media, please do so. We can chat and discuss anything you want. So as a company, as a CYBERTEC, we have our proprietary Postgres-based products. Some of them are on the slide. So Scalefield is like an AWS on your own hardware. CyBETEC is like visual editor for creating forms and applications. Migrator will help you to move your data out of Oracle and later from MS SQL to the Postgres. Data masking allows you to mask your data for outside of the world. PGE stands for Enterprise Edition of Postgres. So on top of the vanilla Postgres, we have some extensions, some functionality that suits like the corporate level users' needs. And Postgres TDE means transparent data encryption, which allows you to encrypt your data on disk. So agenda. I will briefly touch the different levels of database monitoring. When we are speaking about monitoring, what is this, right? Then I will shortly describe what kind of Postgres monitoring approaches we do have. Then I will present the most obvious, the main features of PGWatch, and then we will go through top 10 use cases of how we can fix some issues for DBAs and developers with PGWatch. So yeah, first of all, do we want to monitor? Of course we do. We want to know if we're running, if we are down, if we're slow or we are fast. We want to make some predictions. We want to know what is the price will be for our cloud platform or our other services. This is not a question. So the question is how to monitor, right? So I would say that there are like three approaches, 3 levels. So the first one is the high-level service availability, just so we know we are running and we are flying, right? The next one is the system monitoring, when we are talking about the operating system and the hardware we are running on. And the third level is the Postgres, when we're talking about specific Postgres features like memory consumption, I/O, and all these things, right? So for high level, it's not that hard, right? So everyone can come up with the do-it-yourself script or ping or whatever utility just to constantly check if we are running or not. If we are talking for system monitoring, there are a lot of tools, and this is like area of system administrators mostly, right? So they should know how to monitor system-specific metrics. For example, what CPU load and what are the different memories metrics are, what do they mean? But if we are speaking about Postgres specific monitoring, we can break it into 3 main parts: log analysis, statistics collector, and extension. So log analysis is crucial for Postgres. So if you don't have anything external, no monitoring solution, nothing, you have only Postgres, the first thing you always need to do if you have some problems or you want to investigate something, you go to Postgres log, because everything important, everything life changing for your system will always go to the log, always. Of course, probably you want to parse that log and to present it in some kind of useful way. So, for example, standard de facto nowadays is a PG Badger. It's really cool. So you can customize your log output, then send it to PG Badger and have a lot of analytics and have a lot of like insights in your data. The same for Grafana Loki, which like is created especially to handle logs. So I mean, it's up to you. But the main part is, if you want to have as much as possible information from your log, you always need to tune your Postgres settings. For Postgres 17, we have 43 different logging and reporting settings, right? So, that means a lot. So you can control pretty much everything. So you need to go through all of them and to tweak it and to make sure you have all the needed information, right? The next main part is statistics collector. A statistics collector is the part of the Postgres, is the Postgres machinery that runs inside Postgres, right? And we can, so basically it's the set of system views. And we can divide these views into two general parts: the dynamic views and cumulative views. Dynamic views shows you the information like right now. So what's going on right now, like PG start activity. You will see what happens right now, right? PG logs, you will see what logs are actually there right now. And cumulative views, the name of them hints you that you will see the data that will accumulate it with the time, right? That means sometimes if you want to solve some weird or hard problem, you might want to reset your statistics before applying new workflow and before investigating the new things, right? So the all accumulated data before you started your investigation are not in no way like influence your like thoughts and decisions. And yeah, statistics collector views are accessible through regular SQL, so you can query them with any client and use the data as you want, right?
Pablo, one quick question here. One quick question, just to spice up the conversation that we are having here, right? In your honest view, right? What are some of the underrated PostgreSQL views or extensions that engineers often overlook, right? And when we are setting up monitoring, or when we are setting up buying observability tools, with so-called AI things, right? At a very base level, at a foundational block level, right? What are some of the underrated Postgres views and extensions in your view?
Well, it depends on your workflow, but I would say that the PG stat statements is the must-have extension on your node.
Right.
I mean, it's not in the core. But I mean, it's so useful. It produces so like little of like heavy. I mean, a load on top of it. So I think it should be in core and it should be installed by default. Really. So we should install it by default, and then if you want to, you can disable it, right? But I think it should be enabled because it's so useful, really. And other extensions that will increase the observability So pgstat statements is like the must-have. pgstat monitor from Percona is a pgstat statements-based extension. So it kind of enhances the pgstat statements. Then, if you have to know, if you want to know about your tuple bloats or table bloats, you might use pgstat tuple. If you want to see what's inside your buffers, thread buffers, you can use pg buffer cache. Auto explain will help you to see the plans for really real-time executed queries. So the only drawback of auto explain that the output of auto explain usually always goes to logs, right? So I'm not sure if at the moment we can just like write a select query and get the Cyber explains from it. But yeah, for this one you will need to investigate the logs. pgqual stats will provide you with the statistics about the your where predicates, and pgstat kcache will help you to get the operating system metrics like CPU, memory, disk, and so on. I'm not sure pgstat kcache supports every possible operating system. For example, I'm not sure about Windows, but I mean, for most of the users, for most of the deployments, it's really useful. And yes, we have a lot of monitoring tools and extensions and whatnot. You can find all of them on the wiki page you see right now on the monitor. The only warning here is some of these tools, some of these extensions might be dead, or how to say it, not very actively supported. So please pay attention. But if you will find some outdated extension and you think it's very useful, just like grab it and then send a pull request to the author, and we will be all happy. Or just adopt it and become a new maintainer. That's how it worked with pgwatch, for example. Okay, so pgwatch and its features. First of all, I want to thank Karl Moppel, my former colleague at CYBERTEC. He was working on pgwatch version 2. If you will ask me what happened to pgwatch version 1, nobody knows. We have a legend that pgwatch version 1 is kind of Python script, and it was running somewhere in basement of our client and producing some simplest dashboard and simplest data. And it was like it was the push the idea of, okay, we having already this script, we need to have something like more useful. And at that time, Karl stepped in and started to work on the version 2. So the main principles of the pgwatch. So we want it to be one binary, just like you have one binary and you don't need anything at all. No YAMLs, no JSONs, it's everything inside. Okay, if you want to enhance it, you can do it. But if you want to be just like, imagine you have a USB stick and you are in the middle of the, I don't know, forest, and you have some secret Postgres server, and you just put the USB stick, and the only thing you have is pgwatch binary on it. And that's enough. You can work with it, and it will produce some data. So, of course, we want to have the ability to users to have a rich visuals and rich dashboards. But we didn't want to limit our users with our own dashboarding like implementations. That's why we decided that the Grafana or T3 or other famous solution in the world will work perfectly. So at the moment, you are not limited as a user to any dashboarding. You can use Grafana, you can use Prometheus dashboards, you can use your own dashboards. And the themas is non-invasive, meaning that to run pgwatch never ever would try to get an access of the super user. The maximum we want for PG Watch is PG Monitor role, which is created for the monitoring functionalities. The easy extensibility means that if you have some special workloads or special deployment and you're interested in some custom metrics, for example, how many phones did I sell yesterday? This is a metric. Yes, you can write your own SQL. PG Watch will use it as a metric definition and will provide some measurements. Later, you can add it to dashboards, and at one place, you can have system measurements, you can have your business analytics, so you are not limited in no way what kind of data you are collecting. And about alerting, so this is like a hot topic. I personally think that alerting is not the same as monitoring. It's completely different beast. So yes, alerting is based usually on some kind of real-time monitoring, but PG Watch is made for continuous monitoring. So the main idea of PG Watch is to have the ability to look back into the past, like months ago, and compare what changed our system. Okay, so we released a new version of application, and now we have 200 more transactions instead of 100 less that we had months ago. Let's investigate this kind of thing. And when we are talking about alerting, we're speaking about real-time monitoring, right? So every 10 seconds we have some metric, we check thresholds, and then we react. So it's kind of a soldier that needs to be always ready to react. And PG Watch is an astronomer that collects data about everything, and then we can investigate things. So architecturally, it's as I said, it's really one binary written in Go. And of course, you can have your own configuration, and for that you can use Postgres. For that you can use YAML. For that you can specify some environment variables. Then where to store measurements. For that you can use any flavor of PostgreSQL, including timescale DB, including Citus, including Cockroach DB, name it. Then you can use Prometheus. Why it's useful? Because Prometheus is the standard de facto nowadays, and Prometheus has alerting system in it. So if you want to somehow implement alerting, that might be useful to send data to Prometheus, and there in Prometheus to configure the alerting. Of course, you can send your data to local file, and you send you can send data to RPC, the remote procedure call. So you can write your own application that will receive the data. So, for example, during the last PGConf Europe, we had a presentation that during the Google Summer of Code, our student implemented the PG Watch Sync PG Watch Sync that accepts the data and send it to AI bot, and that AI bot produces some insights based on this data he got. So it was just a proof of concept. Of course, you need a more powerful model, you need more powerful hardware, and probably you need a special model for that. But I mean, that's how we see the usage of the RPC. And yeah, we have Web UI, and we have Grafana. We have a question?
Yeah, hi, this is Prateek. Thanks for this. One quick question. Often we see PG Watch kind of agents work as a sidecar of a single Postgres, but in real life production grade systems, then there might be a cluster of Postgreses working with a cluster manager like Petroni. So does PG Watch offer a cluster-wide observability, or are there any good industry practices around it?
Okay, great question. Thank you. That's why I have architecture components diagram for you. So the task of PGWatch is to control and monitor Postgres. But you're absolutely right. Postgres can be controlled and managed by Patroni, right? So how can Patroni help us? Patroni can tell us what nodes are in Patroni cluster. What are the roles of those nodes? So Patroni can tell us, okay, we have node 1 and it's a primary, and we have like node 2, it's a standby, and we have like node 3, it's, I don't know, whatever, synchronous, asynchronous, right? Okay. So knowing this information, PGWatch can take connection strings for those Patroni clusters and add them on the monitoring automatically. So at the moment, we are not monitoring Patroni. So we cannot say if Patroni is good or bad, how things are going on. We are working on it, but we are not here. We're not there, sorry. But how we use Patroni, we communicate with the Patroni to obtain the information about all nodes that are in Patroni cluster. So this way, for example, if you have a list of Patroni endpoints, UTCD endpoints, and you're not willing to add Postgres by Postgres, node by node to your monitoring, you can add the endpoints of Patroni to PGWatch, and it will connect and automatically will create the monitoring profile for every Postgres cluster it will find, right? And so that's how we use Patroni. Is it the answer on your question?
Yeah, one follow-up to that.
Yeah.
So what I imagine is once you fetch metrics for multiple Postgreses, depending upon their roles, you may want, and depending upon the metric, there may be a need to aggregate them. For example, database size or file sizes, they need to be summed together. CPU utilization may be taken as an average. Aggregation of a same metrics across a cluster, right? So is it, first question is it solvable with PGWatch? Second is, if so, then which one of the PGWatches does it? I'm imagining PGWatch for each Postgres.
Yeah, okay, I got it. So PGWatch itself, can you see my mouse? Okay, cool. Like this. This is the PGWatch. So PGWatch itself, it uses the method definitions, it collects everything, and then it sends to the sinks. There are sinks, right? So about the aggregation. If instead of PostgreSQL, you are using timescale DB by, for example, or Citus, or anything else that is able to do this, then, I mean, my answer is you can do it, but you will do it on the measurement storage side. So PGWatch doesn't have like temporary storage to hold previous values and then to do things with it, because we are so small and so heavy loaded. So we need to act as fast as possible. We cannot we are already like 400 databases. We will use like a lot of memory. We're trying to solve it, but I mean,
because Prometheus does come with a lot of pre-computations and other expressions, support for aggregations. So it makes sense to do these aggregations in the storage layer in Prometheus, right?
Yeah, exactly. That's why you can send the data to Prometheus, and you will have your aggregated data there. Yeah, sure. So it's not very rare in our client setups that they use Prometheus for like alerting and kind of dashboarding, and then they use like Postgres or files for long-term storage, like for later, you know.
Yeah, my 2 cents on Pratik's question, Pablo. So we are essentially building a lakehouse on top of our monitoring data per se, right? So if you look at it from a data ingestion standpoint, that we are kind of building, we've got a fleet of database instances. So we're building a lakehouse for the monitoring data of those fleet of database instances, right?
Yeah.
It'll be a great feature addition to PG Watch, probably PG Watch 4 or some stuff. But yeah, that's the I look at.
You are open for that.
Yes.
And we have indeed we have an open architecture. So this thing that we have RPC sync is especially for that. So I know that we as a developer, we cannot cover every use case on the planet. That's why we produce the API that you can use to create your own solution based on the API we produce, right? So instead of like collecting data and store it, you can do online computations, right? So we can like calculate the averages immediately as we receive the data, or we can send it to AI, or we can do, I don't know, whatever we want. I mean, that's why. So this is not, I believe this is not like the core functionality of PG Watch, but it may be done with the extensibility, with the API.
The RPC approach, I see an advantage to integrate with systems like InfluxDB, which accept an RPC as like they expose an endpoint, and the agent needs to call an API to, which is completely opposite of Prometheus model, where Prometheus makes a call to the agent.
It's interesting. The one of the first versions of PG Watch 2 used InfluxDB as a default storage, but then we find out that Postgres it's like much better in storing time series. So we just said, okay, there is no need to have both versions, Influx and Postgres. So we stick to the Postgres, but at the same time, we add Prometheus as a first class citizen, of course, and we have this RPC. I mean, if anyone will write a great piece of software based on this API, and we will see like the usefulness of it, I will be more than glad to include it to the core. Really, that's not like we don't want anything like bloat or whatever. We just need like a real life usage. If you need it, if you use it, and you come up with the real solution, I will be more than glad to include it into the PG Watch core. We have a question about how PG Watch better than Grafana, which is famous in this field. Thanks for the question. So as you can see, Grafana is here. So PG Watch is not the replacement of Grafana. PG Watch is a collector and producer at the same time. So what PG Watch does, PG Watch knows everything about Postgres, everything. And it collects the specific Postgres data, put it into specific metrics, and send it to the sink, Prometheus or Postgres. And then, as a user of Grafana, you can use Prometheus and Postgres to build your own dashboards. So no, PG Watch is not a replacement for Grafana. Grafana is our best friend. Grafana allows us to visualize everything PG Watch produces. And please use Grafana. It's the cool open source project.
All right, Paulo, let's, in the interest of time, let's jump to the use cases that we want to look at.
Let's go to use cases. Otherwise, we will. Okay, so use cases, right? The first one is really simple. So as I told you, PG Watch is simple in one binary, but it's usually hard to understand how you can start, right? Just like immediately. For that purpose, we built a PG Watch demo image container, Docker image container. this is quite big Docker image. Inside of it, you will find Postgres. Inside of it, you will find PGWatch, and inside of it, you will find Grafana, all in one. And the only purpose of this image is to show you what you can achieve without installing anything. So you start this container, PGWatch demo. You wait for some seconds when it starts. You open the web UI. You have your connection string for your Postgres database. You add your Postgres database under the monitoring, and in some time you can watch already collected data without installing anything. It's all there, right? If you don't want to somehow collect your data with this container, you can go to the demo.pgwatch.com. There we have this container running every time, updated after each release. So every dashboard that is available in our repository is there. Not all of them are working. For example, some specific cloud dashboards are not working because we don't have cloud instances on the site. But otherwise, you can see how it looks like. So how it looks like. Okay. So the use case number 2. Let's imagine we have a DBA or developer, and they are troubleshooting like performance issues like on a production database. So users report, oh, we have some slow queries, but we cannot see a clear pattern. And your goal as a DBA or developer to identify the slowest queries, to understand the execution times, understand patterns, and then determine what are we missing here, maybe index, or maybe some query optimizations, or maybe some ORM things related, right? How we do this? So first of all, we are running, okay, so for every use case here, for every scenario, I'm assuming that you are running PGWatch, right? And you added your database under monitoring, and the first thing is always like the PGWatch is running, and we have enabled stat statements metric. By the way, we have 35 built-in metrics in PGWatch at the moment. They are not divided, but they are some part of the presets. So we have basic preset, we have full preset, we have standby preset, things like this. We have PG bouncer preset. So if you don't need all of them, and probably you don't need all of them, you can choose either preset of the predefined metrics, or you can pick one by one. So here I'm telling that, okay, let's assume that PGWatch is running and we have stat statements metric. That's the name of the metric, enable. That means that we will use PG stat statement extension. So we need to make sure that it's in shared. Okay, so in this case, we need to be sure that the PG stat statements is in preload shared libraries, and we need to make sure that the create extension command executed. So we have this extension, right? So we collect data sometime, maybe for a day, maybe for a week, depends on your workflow. And then we go to stat statement stop dashboard. So here is the Grafana, how it looks. It's version 11. The latest one is version 12. We are working on it. So you're going to stat statement stop this dashboard. Let me make it bigger, right? So what we see here, for example, so this is the data for last 3 hours. And this data is collected for monitoring profile demo. And we have profile demo standby. The name says you that they're like one is primary, one is standby, right? But you can name it whatever you want. Maybe you can choose some names based on like a region or operating system, whatever. And you can see that we have how many top 10, top 5 queries we want to see. And we can specify if we want to hide PGWatch related queries or we want to show them. So we put this edit here just to prove to everyone that PGWatch doesn't produce heavy workload. So you can always like enable everything and see that PGWatch is not in the top even 20 maybe. So okay, so here we can see these top queries by total runtime. Probably this is like the most useful panel for you to start your investigation, right? So if the query takes 40% of the total time, probably this is your like the best candidate to understand what is going on, right? Here I'm not sure, like so we have update, we have select. So if you are familiar with the PGBench tool, so all of these are like standard PGBench queries. Next one, we have top queries by average runtime. So you can see like in average what is the slowest query. I'm not sure how much it can tell you. I mean, maybe you can find here some suspicious queries that shouldn't be there, right? So you are completely sure that your query must be fast, like less than nanosecond, but it will appear here. Why? Probably some locking happened, something happened, and you need to investigate. Total number of calls. So you may want to decrease the number of calls for some queries, or you want to combine some queries into one transaction, for example. I'm not sure. Then you have total queries by direct I/O and by the bandwidth. So here is your like dashboards you can investigate. So if you are not happy with top 5, you put top 10, and then you have. But we have only 6 here, 8. Let's reveal the PGWatch related queries. So this one, for example, PGWatch generated. So this one is trying to have the CPU utilization on the host. As you probably know, we cannot get this information directly from Postgres. That's why we use the PL Python function, so untrusted language, so it directly get the information from the host. But as I said, if you have already system monitoring enabled, then probably it makes sense to disable PL Python related metrics at all. Okay. Next one, detect. We have a question? Okay, so detect performance spikes. So again, you are as a DBA, you want to see, to analyze why we have a sudden increase in CPU, RAM, disk I/O, on very basic Postgres instance, right? And the goal is to find the query responsible for this thing, or maybe some background maintenance query or task or something like that. So for that, we want to be sure that PGWatch is running, and we enable some system and Postgres resource metrics enabled. There are like a bunch of them. You will find them. And then we have several dashboards that can show us the performance things. First one is system stats. If we go into our dashboard, we have the system stats here, and we can see like for, okay, last 3 hours. We can see here different different panels. One is for system load, another one for like CPU utilization, CPU usage, memory usage, swap, disks usage, and disks available. So you can check here how your system behaves. Another one is database overview. So if we go to database overview and we check general database activity, which is this one probably. So okay, we can tell here. 3 hours. We can tell here, right? So how many tuples were inserted, updated, deleted, shared buffers, here hit ratio, transactions per second, queries per second, how many sessions, what was the wall rate and in the size of database. We have CPU load and average query runtime here, so you can somehow see the correlation between the average query runtime and the CPU load. We have a question, Pratik.
Yeah, a very small one. I don't want to extend the time also. Can I figure out what interfaces does a PG Watch use to measure system statistics? Because each system, like operating system or containers or Kubernetes, can have its own nuances to measure CPU, memory, disk.
Okay, good question. So let's go. This is. So let me show you the code.
Oh, wow.
Yeah, that's how it works. So you see, we have, for example, we have a CPU load metric. We have a description. Then we have an SQL. That means that from 11 major version, every version is okay. So 17, 18 will work. So what we do, we are getting the results from this get load average function. But what it is, we don't have this function, right? Then we come to this init SQL section, and it shows us that we need to have PL Python untrusted language, and we want to create this get load average average function, which in fact calling get load average from the Python, right? And then we just return this. What we have here. So we have here overhead of calling PL Python. Yes, we do. But this is like the only sane way to obtain the system information from the system. Another one would be PSUtil as CPU. So PSUtil is the bunch of components, the bunch of classes, right, in Python as well. So they provide you not only with the CPU, they provide you with a disk, with memory, so PC. They provide you with the disk with memory. So with that's how we like. This is like a cheat code, right? So we are using untrusted language to access the operating system results. Now, your question is, what if we are running on Kubernetes, or what if we're running on some like virtual machine or whatever? It's the responsibility of the host to provide you with the up-to-date information. So I believe if your Kubernetes provides you with the accurate numbers for CPU statistics and disk and memory, you will get it here as well. But yeah, I always say if you have opportunity to collect system metrics in the same way, do it, because Postgres is not for that. We are doing this only because like some people don't want to bother to deploy another like system monitoring or whatever. That's why we have this for ages. And every time when I'm trying to mark this as a deprecated, people say no, we are using it. It's good. It's okay. Just leave it. So it's here, just like an art of cheating, but it's not really the best approach to measure the system metrics. Okay, so how much time do we have? 4 minutes?
Not much, Pablo.
Okay. Let's try the bloated tables. So if we go here, so we have special dashboards for these, like table details and the check pointer and whatnot. What I like the most is the biggest relation tree map. I really like this visualization, because here you just like have all the biggest objects on one page, and you can tell, okay, just hover on the table name and you will see. So this is like the total relation with indexes. This is without indexes, and this is like the biggest index. So if you can see here some like unused index that is bloated, probably you are not using it. I don't know. Maybe so. Yes, and log contention. Okay, replication lag. So this one is hard to show in PGWatch.com, demo PGWatch.com, because you need to set up replication. But I did before this talk. I set up replication. So if we go here. So here you can see that we have some replication-related metrics, like do we have log, do we have replay log, how many active, how many inactive, and yeah, of course you can change thresholds for every panel, and from green they might become red or blue or whatever. Another one, it would be. So, okay, index efficiency, we have this, and pooling issues. For example, if you're using PG Bouncer, I deployed one. So this dashboard can tell you about how your PG Bouncer is going, right? So here we have like transactions per second, queries per second, average queries. Pool wait time 0 means our pooler is perfectly working, no delays, right? So, and you can see incoming traffic, outgoing traffic, and things like this. So this is like this is so everything that PG Bouncer provides us in terms of monitoring, we put it here. Not that much really, but I mean, you can tell that you're doing bad or good, right? Another fun thing is detect changes in the settings. So if someone change the options in your Postgres database, you can examine the dashboards and see what exactly. Let's check change events. Change events here one. So you can see like this is like the graph showing the number of changes, and this table shows us what changes. So okay, so it's time this I don't know why it's minus whatever. So someone dropped the table PG bench accounts. Wow. Should it be alert or not? Should we investigate or not? Someone create, someone drop. The same for indexes. Someone create, someone drop, and much more. And this one, the lowest one, is just for settings. So yeah, you can tell that Now the settings for AutoMacom is on, and the scale factor is 50, and then when you can change. And by the way, the same goes for privilege. So sometimes people are struggling to grab the moment where one role became more than it should be, like super user, for example, or something like that, or obtain some unneeded privileges. So the privilege changes will be listed here, and DBA can like walk through them and understand what we need to do about that. So yeah, that's basically it. The PDF, the presentation will be available for you, I hope. Yes, sorry?
Yes, that's correct.
Yeah, sure.
And the recording of this is also available on the website, on the landing page where you guys have registered for the webinar.
Yeah, don't be a stranger. If you have a question right now, but you're a very humble person and you don't want to ask it in front of other people, you can send me a message on LinkedIn or create an issue in GitHub repo, or create a discussion in GitHub repo. That's absolutely. I'm very grateful for all of you who somehow helped me improving the product. Every feedback is like really useful for me.
Sweet. Aman, you're talking on mute.
Hey, thank you all for joining us. So it's a wonderful talk by Paolo, giving us a live and then real field insights. Thank you, Paolo, for that one. And as Paolo already mentioned, right? So you guys, you don't need to feel alone or think that, okay, hey, where will I get this information? You can always reach out to us, like either on our LinkedIn pages or on our means like the sites for the LinkedIn pages for both OSDB as well as the CYBERTEC. So one of us will actually respond to you. So if you message us, you will actually definitely get the things. And also we will share this details of this presentation as well, so that way you have information. Again, so I'm just reminding you, in case if you guys need a customized demo or something, you have a requirement to CYBERTEC tools, please reach out to us. One of us will actually help you to set up your systems. And I'm sure this session must have given you some actionable ideas, and then strengthen your PostgreSQL observability, and then the pusher for the high performance of your database. So we are always there to help you, and then lend our hand your database to be more healthier and then the more better. Thank you. Thank you again. Thanks again for joining us.
Thank you, everyone.
Thank you,
Thank you,
folks.
Paolo.
Thank you. Thank you. Thank you.